In the lab where acids do reign, and potions do boil and ferment, I, a chemist, do toil in pain. My stir bar is lost in lament. I search high and I search low for the small but crucial tools, but alas they seem to flee, like a thief that breaks the loaves. For without the stir bar's aid my experiments do fall. My progress hindered, my hopes frayed, my frustrations at the wall. I doth try magnets, tape, and glue to keep them in my grasp, but they still vanish out of view. My lab, now stir barless clasp. Oh, my mind is full of woes, as I loseth more than I know, but perchance one day I'll find the key to keep them safe and my frustration free. So let this be a lesson to all, to keep a careful watch on thy stir bars, large and small. For they're essential to our work, we see, and losing them can lead to much agony. You know, 1 minute they're there, and the next minute they're just not. Where did they go? Why are they doing this to us? You know, 1 minute they're there, and the next minute they're just not. Where did they go? Where are they? Why are they doing this to us? So I posted this on the Reddit machine, and this one guy came in there and was like offended. He was like offended. Okay. He was like, this is the worst poem I've ever read. And he was like, it's so terrible, there's dews everywhere. He didn't understand that it was written in like Shakespeare style. It was just so funny. He was genuinely offended by this poem. And it's like, dude, this is Reddit. This isn't like a graduate poetry class. Like, what are you doing? You know, it's been 7 days since the last video. 7 days. That should be a crime. I am sorry. But behind the scenes, I've been hammering down on the synthesis. And holy crap, it's been fighting back. There's definitely been some highs and lows, and basically the last time what it did was it just cooked it. So during the methanol sodium hydroxide addition, I cooked it. So I wasn't paying attention to the actual graphic on my paper that I was following. It said 5 degrees C quite clearly. I was just following what was in the writing. So this time we are going to try this, what the author told me to do, at 15 to 20 degrees C, and see how that works. It's really been fighting back. I had to backstep slightly and re-brominate. Other than that, you know, this process hasn't been too bad, but there's definitely some roadblocks that I have been running into, which you'll see in the video. I really hope you enjoyed my suffering. And then on the side, I've been preparing things for the next steps. So I've been preparing ethyl acetate, which from scratch is quite the task. You know, from baking soda and vinegar to, you know, extracting ethanol for hand sanitizer and, you know, doing the Fischer esterification reaction by reflux, and then distilling and then treating and then distilling. It's like 5 distillations before you have ethyl acetate. So, because that's needed for the protection step, which we'll be doing next. So sit back and relax, and I really hope you enjoy the video.
Here we are on take 2, just doing our bromination real quick. Things seem to be going quite well here. I'm doing a slightly smaller scale because I made a little bit less dioxane this time. I used whatever ethylene glycol I had left. So Alright, take 2 here. Changes, we've added an ice bath, and I have chilled the methanolic sodium hydroxide, and we are not to exceed 20 degrees Celsius. The hard ceiling is 30, so we will use 10 degrees as a safety window. Just bought a brand new rotary evaporator. It's pretty sweet. We're also doing some studies on the caged ion down here. This is an extraction attempt because my funnels keep clogging, so it would be mixing the solution in water to crash out the solid, and then mixing it with a little bit of hexane in a separatory funnel to pull that solid out into something that's a little more volatile, and then separating that out and trying to evaporate it. As you can see, it's a little engineering required, but it's going, and there is solid in there, and it is a beige color, which is what we want. Alright, so this is Rotovac V2. A little bit of cutting edge engineering, and we have something that might work slightly. Yeah, just a weak vacuum on it. Just pulling about 6 mercuries on it. So we'll see how this works. Okay, so after 2 straight days of doing a bunch of different things, it seems like we might have found a method to actually extract our product here without having to use the vacuum filter or, filter anything excessively. And it appears to have worked. We'll run a a melting point test on this, because we're at 180 or between 180 and 185 degrees should be our melting point, and we have used hexane to draw our product into the hexane layer from this water layer, just because it's extremely difficult to filter out of that water layer, and I don't really know. You must, whatever happened with our reaction conditions, our particles are just way too small for my vacuum filter, and way too slow for gravity filters, because I've obviously been trying that as well. So what we've done is used hexane to draw it up into that layer. Then we'll separate the water layer out, and I will just pour this over a gravity filter, and then it looks like that. So this right here, there's not a lot, but obviously it's just a pilot project, because I was doing like 5 or 6 different things to try and do this. So this is about 1/10 of what I have. So I'm definitely going to be taking a break for the rest of the night tonight after the melting point test, but I will continue on with the other amounts of the product. And the good thing is, after you filter this hexane down, you can reuse it. It comes out extremely clear. It's basically just being used to pull that product out. So really, really easy, really repeatable, and no vacuum filtration. So I'm happy with our results here. Okay, we are at 171 right now. All of this work hinges on this. It's been days of me trying to get this product. I made this product, but getting it out of solution has been the problem. But we need to verify its melting point, because we don't have an NMR, obviously. So that's how we're gonna verify it, and we're getting close. So about 172. Alright, we have just started melting here, and look at that. On the money. The top number is our test tube. Bottom number would be the oil. Beautiful. Alright, we are just distilling some ethanol for our ethyl acetate in our next step. We already made the glacial acetic acid. I did not get any shots of that. Basically, you just do the mix salt and vinegar and boil that down to get sodium acetate, and then you add sulfuric acid to that in a flask and distill that over, and that's your glacial acetic acid. So once we get this, we'll mix the two together, do a bunch of stuff, get ethyl acetate, and we can combine that with hexane and do our deprotection. Okay, so we are just making our ethyl acetate real quick. We are refluxing glacial acetic acid and ethanol. So it is a Fischer esterification process. I'm not going to bore you with the details, but basically we're just refluxing ethanol and glacial acetic acid in an acidic environment. So we've added a little bit of sulfuric acid. After this, we're going to have to distill it over and then treat it and then distill it over again. And we'll have our ethyl acetate ready for the next step.
Okay, so it took days of experimentation and trying things that weren't even in any of the papers before, and we actually did it. We actually got our product. You're going to have to pretend that there is about 1 gram in here because I have already started the deprotection. So my yield is about 1 gram of this product that has a very long name, and I really don't want to read it off. There's lots of numbers and dione and yeah, just pretend. So it's really difficult, and I'm not sure where my shortcomings are, whether it's my vacuum pump, which is only pulling 6 mercuries, so it's pretty weak. So it definitely could be there. My vacuum filter isn't the best. I mean, I got the thing on Amazon. So that was definitely getting clogged. I tried pulling a larger vacuum on it with my larger pump. The thing is just so loud, and I have to go to my different site to use that pump, really. I even tried building a sound box for it here. It didn't work. And also what was happening was the precipitant, so small, it was pulling through the vacuum filter as well. So I had to do gravity filters. And what I discovered was, one, I only refluxed for 3 hours, which I should have refluxed for 24. 2, I diluted it in way too much water. I diluted it in like 4 times as much water as the paper does. So what I ended up doing, and this may have actually ended up helping me, was I distilled off some of the water. And I think what that was doing was, since the temperature was raised, it was driving the reaction a little bit further and helping it, because without extracting some of the water first, I would try the hexane wash and it just didn't produce results. So I would fill a 1 liter flask and take off about 500 mils. And then I would wash it with hexane after it cooled down and see the precipitate in there. And it was successful in that way. And I was able to pull the precipitate out of that huge water layer into a tiny, like 100 mil hexane layer, and then easily gravity filter that. Just dried the filters for a few hours. Hexane evaporates really easily, and just scraped it up and threw it in here. And we got about 1 gram, which is awful. That's an awful yield. So I have about 25 milliliters of ketal left. I just made some more bromine. I am going to redo this reaction with 25 mils of ketal, and I can almost guarantee that I will get more than I got here, even though I used double here, because of the things that I've learned. I'm going to reflux longer. I'm going to take more. I've already made the bromine off the scenes. But I have taken greater care in my bromine quality. Last time I just kind of distilled it over. I had an NaOH trap, and I had sucked back into the bromine, and I didn't even care. I just threw it in a step funnel, and then just pulled the bromine off and threw it in. But I did it right. I went to a different location, my second location, the garage, where I didn't have to worry about the fumes as much. So I was able to make much purer bromine. I didn't have a NaOH trap, so I didn't have any suck back. So it worked really well. I think that's going to help us a lot. I'm going to use more bromine because I wasn't using enough, allegedly. I went back and checked the paper again, and I really wasn't using enough bromine. So for 25 mils, my next run, I'm going to be using 30 mils of bromine. So a little bit over that 3 molar ratio, which is what it technically is. So a little bit of bromine in excess. So we're going to give that a try, and see what we get. But the most important part for our journey currently is this. And so, like I said, I've already started the bee protection. That is a 30-hour process. So it's just about done now. It'll be done tonight, and then I'll have to wash it with ethyl acetate and hexane at different concentrations and recrystallize it a couple of times. And we should turn this brown liquid this brown solid into a colorless solid. And then we can do our flow reaction and hopefully make some cubane, which we're getting close. It's really exciting. We did start on a decagram scale, and now we're on a milligram scale, but that's okay. We're still going. We've been having success. The boiling point test was literally on point, 180 degrees on the dot. So very exciting things are happening here. We're trucking along. Like I said, fighting it as hard as I can. It's fighting back, but we're winning. Like and subscribe if you like what you see and you'd like to follow along with the journey, and let's make some cubane. And we'll see you guys later.